Welcome back to Discovering Geometry with Mrs. Berry. This is lesson 31. We will be looking at properties of different polygons. Today we will look at the properties of kites and trapezoids. So remember that a kite is really a quadrilateral with exactly two distinct pairs of congruent sides. A kite is like constructing two different size isosceles triangles on either side of a common base and then removing the base. In an isosceles triangle, the vertex angle is the angle between the two congruent sides opposite the base. So let's highlight what that looks like. This right here would be one isosceles triangle with this base in the middle. And this one would be the second one with this base in the middle. So this side and this side are equal, congruent, and this side and this side, because of the first isosceles triangle, are congruent. So in our kite, we will call the two angles between each of the congruent sides the vertex angles. In a kite that we would think of flying around, that would be the top and the bottom of the kite. The other two angles we will call the non-vertex angles. So in our first investigation, we're going to need patty paper and a pencil. On the patty paper, draw two connected segments of different lengths. Fold through the end points and trace the two segments onto the back of the patty paper. So this is going to make us a kite with half drawn on the front and half drawn on the back. Compare the size of each pair of opposite angles in your kite by folding an angle onto the opposite angle. Are the vertex angles congruent? What about the non-vertex angles? You might want to draw a different kite to compare those as well. After that, we'll draw in the diagonals. How are they related? Are they the same length? Are they a certain angle to each other? Check both kites that you have drawn. What else might be true about the diagonals of the kite? We can compare the lengths of the segments, or we can look at if they bisect each other. Then fold along both diagonals one at a time. Does either diagonal bisect any angles? Here's what that looks like. Here's my two connected segments. Then I'm going to fold right at the endpoints, and I'm going to trace those two segments onto the back of my patty paper. When I open it up, I can see through, and so I can see my kite. I'm checking, and I do have congruent angles there, but my vertex angles are not congruent. Drawing in the diagonals. Oh, they look like they're all 90 degrees. What about measuring the diagonals? Well, that one's bisected, but that taller one, that's not bisected by the other angle or by the other diagonal. But we can tell that that diagonal does bisect the vertex angles. So what are some conjectures that we can draw from all of this? In step 2, we saw that the diagonals, in step 2, we saw that the non-vertex angles of a kite are congruent. So when you folded it over on what we would maybe think of as the top and the bottom, we saw that the angles that we had already drawn were congruent because we traced them. So we saw that those non-vertex angles were congruent. In step 3, we looked at the diagonals. They intersected each other at 90 degrees. So the diagonals of the kite are perpendicular. All 4 of those angles were 90 degrees. In step 4, we saw the diagonal connecting the vertex angles is going to be the bisector of the other diagonal. Now both diagonals do not bisect each other. In our picture, that was the shorter diagonal that was bisected. It was bisected by the diagonal that connected the vertex angles. In the last step, we found that the vertex angles of a kite are bisected by a diagonal. So those vertex angles are cut in half by that up and down diagonal. Next, we're going to look at trapezoids. So, what was our definition for a trapezoid? It's a quadrilateral with exactly one pair of parallel sides. Here are my parallel sides. If it had two sets of parallel sides, we would call it a parallelogram. A trapezoid has exactly one pair of parallel sides. We call the parallel sides the bases. A pair of angles that share a base as a common side are base angles. So the two on this base are base angles together, and the two on the smaller base are base angles together. We generally also list the height as one base to the other, and we will learn later about the midsegment that is halfway between the two bases. So what are some properties of trapezoids? We're going to break this investigation into two parts. You'll need paper, pencil, straight edge, and a protractor. Use the two edges of your straight edge, so if you're using a ruler, just on either side of that ruler, to draw parallel segments of unequal length. Draw two non-parallel sides connecting them to make a trapezoid. Go ahead and draw a second trapezoid by the same method that's a different size. Use your protractor to find the sum of the measures of each pair of consecutive angles between the parallel bases. What do you notice about their sum? Is it the same for your second trapezoid? So what does that look like? I'm drawing on either side of my ruler, and then I'm connecting those with non-parallel lines. I'm now going to measure all of my angles. I'm just using my ruler to help me draw out the line so that I can correctly measure it with the protractor. So you can see that those non-base angles on the left side add up to 180, and those non-base angles on the right side also add up to 180. If I were to do that with any other trapezoid, I should find the same pattern. In the second part, we're going to draw an isosceles trapezoid. So an isosceles trapezoid is one where the non-parallel sides are the same length. So those angled sides are going to be the same length. If we use both edges of your straight edge to draw parallel lines, then use your compass to construct two congruent segments. You'll connect all four segments to make an isosceles trapezoid. Measure each pair of base angles. What do you notice about the base angles in the trapezoids? Then draw a second isosceles trapezoid and compare that to convince yourself that this is true of all isosceles trapezoids. The last thing we'll do is draw the diagonals on the isosceles trapezoids. Compare their lengths and check your second one as well. Here's what that looks like. I put two rulers together so that my parallel sides would be a little further apart. I'm using my compass to find a point of intersection from both of those top endpoints that would be the same. I had to draw my bottom base out just a little to get those the same. So I have an isosceles trapezoid. Now I'm going to measure my base angles. And what do you see about those base angles? Drawing in my diagonals, and then I went ahead and just measured them. You could also compare their lengths with your compass. What do you see about the diagonals of this isosceles trapezoid? If I were to draw another one, I should find the same patterns. So from the first half of any trapezoid, the consecutive angles between the bases have a sum of 180. That means they're supplementary. So the consecutive angles between the bases of a trapezoid are supplementary. When we drew our isosceles trapezoid, we saw that the base angles of the isosceles trapezoid are congruent. Also from our isosceles trapezoid, we found that the diagonals are congruent. They measured the same length on our trapezoid. So what pair of triangles and which triangle congruence conjecture would you use to explain why the isosceles trapezoid diagonals are congruent?